Alright, Blake and Carlos are playing on a train. That's great. Angela watches. Angela's the smart one. Well, the train passes Angela. It is traveling at 5 meters per second east. At this time, Blake is running 2 meters per second east, relative to the train toward Carlos, who is taking a break, or being safe. All speeds given for Blake are relative to the train. Identify and label a direction to be positive. How about that way? East. Sketch a motion map based on Angela's observation of Blake's motion. So if Angela's standing over here, like in this picture down here, then Blake's going to look like he is going 7, right? So he's going to look like traveling 7 meters every second. I don't know, I think it looks like that. Whereas Carlos, we'll see one where Blake is only traveling at 2 meters per second. Use the diagram in Part A to determine Blake's speed relative to Angela. I don't really understand the diagram in Part A. Is this the diagram? These are motion maps, they're not diagrams. I'm going to say 7 meters per second. Both the speed of the train and of the Blake add together to make 7. Blake now turns around and runs to west. Using the diagram, Blake's relative to Angela. Well, she is going to see him as traveling at 3 meters per second. She's going to be going the other way. In both cases shown below, Blake is running on a train as it travels, in which case is Blake's speed relative to the ground the greatest. So here we're traveling 20 meters per second east according to the ground. Here we're traveling 10 meters per second to the west according to the ground. Speed is scalar, so speed is greatest. Okay, so Blake says I'm running the fastest in case A. Therefore, I will appear to be moving faster relative to the ground. Who cares what the train is doing? Okay, so I'm running the fastest in case A. Yes, that's true. Carlos, no, the train does matter, but since 20 plus 10 is greater than 10 plus 10, you are right in that blah, 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 blah. And the rest of it's wrong. Angela seems to be the brains of this outfit. Blake is running faster relative to the ground in case B, because Blake's velocity and the train's velocity are in the same direction and add up to 20, but in case A, Blake's velocity is in the opposite direction of the train and they add up to 10. Alright. Well, these really aren't that bad. I'm really sorry about this motion map stuff. Maybe we could talk about that in class if this does not satisfy you. But while the camera's running, I'm not going to go dig out the book and look up the answer. Sorry about that.